Alright guys, this is our last review video. This is our last video for the week. We will be taking a pretest on Friday over some of this information. But this is our last one. It is Mrs. Payne again. I'm doing all the review videos. So our Master Learning Objective, or our MLO for this video is I can identify the domain and range of functions by using the definition. And by that we mean the definition of the domain and the definition of range. So we have two definitions here. The definition of domain is all the x values. So domain is x. Now you can kind of start equating those together. Range is all the y values. Range is y. So we're going to look at three different types of examples for domain and range. The first type of example is just if I have a set of points. Again, domain is x, so I want to look at all my x's. Remember, x's comes first, it goes x and then y. Right now we're going to write it in what we call set notation. So we're going to start with this little bracket. And I think, okay, what x's do I have? Well, I have 2, a 3, a 3, and a 5. One thing with domain and range is I don't repeat values. I have 2's, I have 3's, and I have 5's. And that should be a set notation. So even though there are 2 points that have 3 as its x value, I only need to write that 3 once. Then I'm going to look at my y values. I have a -1, an 8, a 0, and a 3. One other thing I want to think about when I'm thinking about domain range is I want to put them in numerical order. Remember, negatives go first and then positives, right? Think about a number line. So my smallest y is -1. My next smallest is 0. My next smallest is 3.
Aaliyah Smith, please report to the principal's office.
And my next smallest is 8.
Report to the principal's
Ignore all
office.
the announcements. So -1, 0, 3, and 8. Looking at example 2, same type of thing. What's my domain, my x values? 3, 4, 6, 2. Again, I have to write them in numerical order. 2, 3, 4, 6, right? That's counting up. They're getting bigger. Same thing with the range still. 2, -4, -4, 0. My smallest is -4, which again, I only have to write once. And then I have 0, and then I have 2. So that's my first type of domain and range. Then, example 3 is when I have just points on a graph. Okay, so again, domain is my x values. X's are these lines. So I'm going to make lines perpendicular to the x line going to all these points. That happens sometimes. It's the way. So I'm going to go straight from the point up or down to meet that point, right? This one can't really go up or down, but I have this one. Okay? So I'm just seeing where along the x-axis it falls. I don't care how far away it is from the x-axis. I just want to know where it is on the x-axis. So this one, if I count back, is 1, 2, 3, -3. This one, my x value here is 0. It's right at the origin. And here, 1, 2, 3. +3.
David Correia, please report to the principal's office. David Correia, please report to the principal's office.
We are doing the same thing with y. So now I'm going left and right. How far away is it from, or I don't care how far away it is from the y-axis. I just want to know where on the y-axis it is. So, just like we start with our negative numbers here, I want to start with my negative numbers here. So my lowest is 1, 2, 3, 4, 5, 5. -5. Then I have one going right here, which is at the y value 0. Then this one's up 2. And this one runs the y-axis up 3. Same thing for example 4. The only thing different about example 4 is it has a lot more points. And again, if 2 points fall in the same place, in line with each other, you don't count them twice. So, for example, this one here, these two are both on this line, so I would only count where it crosses through once. Here, 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 here. Okay? All of these are going to be in my domain. So, going back 1, 2, 3, I have one at -3. My next one is one forward at -2. My next one is one forward at -1. My next one is one forward at 0. My next one is one forward at 1. My next one is 2 forward at 3. And my last one is one forward at 4. Lines for -3, -2, -1, 0, 1, 3, 4. Lots of parts of my domain there. Now I'm going to do the same thing for my range. Again, we're using the y-axis. And again, for range, make sure you start at the bottom. You're starting with your lowest number. So I have one here on that line. I have 2, but it doesn't matter. Remember, they can repeat. I also have 2 here. Again, doesn't matter. I have this one and this one. Okay? So my lowest part of my range is going down 1, 2, 3, -3. My next one is down 2. Then up 1, up 2, and finally 1, 2, 3, up 4. And so my range is only -3, -2, 1, 2, 4, because it has lots of repeat ones. So that's our second type of function we'll see for finding the domain and range. Our last one is if you really just have like a graph. Okay? It doesn't really matter what type of graph you have. Last year you looked at linear functions, the domain and range of linear functions. So let's start with domain. Sorry, blanking. Let's start with our domain. Again, it's along this x-axis. One thing to remember about these functions, you can't see it here, but they do have arrows on them. Remember, functions continue to go. Okay? Graphs continue going. So I want to know, okay, what's my farthest left point? My farthest left point is right here, right? That point there. What's my farthest right point? I don't have a farthest right point. This is going to continue on forever. Okay? So, my domain starts at 0. Starts at 0 and goes to infinity. My domain has to deal with x values. So I'm going to show you 2 ways to write it. 0 is less than or equal to x, right? Because I actually have a point here on that 0. But x is only less than infinity. You can never be equal to infinity. You can't actually get to infinity. You're always going towards infinity. Okay? The other way to write it is I'm writing domain. I know I'm talking about x. I don't need to have that x in there. Okay? So I just put a comma in between them. So x is understood. I know I'm talking about domain. Then what we do to note that it's less than or equal to or less than or equal to is a bracket, a square bracket. And just the less than sign is a parenthesis. We're going to start using this notation a lot more in this class, so you will get more and more used to it. Okay? All right, let's look at our range. Again, our range is going off this y value. What's our furthest down point? Again, this is going down forever. I don't have a furthest down point. So it's just negative infinity, right? It's going forever. And it's negative going down. For the highest point, well, it's just going up to infinity. This is y. And neither of these are equal because they're just infinity. You can't ever be equal to infinity. So the other way I can write this is negative infinity, and both of these would have parentheses. Last problem, same type of thing. Where is it on the x? Well, again, with these arrows, it's going left forever and right forever, right? There's no starting or stopping point on the x-axis. So my domain is negative infinity, again, going left forever. X, infinity, both of them are less than 10. So again, the other way I can write this is negative infinity, comma, infinity, with just parentheses. There's no equal sign there. My range, going off the y, how far down does it go? Again, this is going down forever. Negative infinity. Y. How far up does it go? Well, its highest point is here, where my y value is 0. So less than. This one's less than or equal to, right? Because it actually has a point there. So how else do I write that? Negative infinity, comma 0. This one's less than, parentheses. This one has an equal sign. That's a square bracket. All right, that is it. See you guys later. Make sure you work on the review activity number 4.